so let's get back to this marks. So we said that we can represent the sequence of cards as a list, right? For instance, if we want to find out, say, the maximum physics marks, then what we would do is we would write out these physics marks, right? So we would say that the physics marks on this are 53 and
72, 64, 78 and so on. Can go on.
Right. So we'll go on and we'll have this.
We'll have
a list with 30 marks because there are 30 students, and then we can do our usual iterative going for each. So we know that, for example,
keep a variable called max, and
we have a variable for the maximum marks, so we can assume it is 0 because we know that nobody has marks less than 0, and then every time we see a bigger mark, as usual, we update it, and this will give us the maximum marks.
Yeah, but we want to know who.
Exactly. So this is the problem. At the end of it, we don't know who has the maximum marks. So now we have to go back somehow
and then see who are the people who got that mark.
Yeah. So it would be actually nice if we could have kept that information also when because we are not interested in the chemistry marks and the total marks and all that. So it's not that we want everything in the card, but we would like, for example, this ID number, right? If we know the ID number of the card, if we know it's card number 3 or if it's card number 0 or whatever.
So we want to keep basically, so then what you want to keep basically is 3 along with 50.
So we want to keep these two things as we go along. So we want to keep like a mini card. It's a list of kind of.
But the 3 and 53 is a list.
Yeah, that's right. So I can just think of that as a list, right?
350. Yeah.
So I can say that
it's a list with only 2 elements. It's a special kind of list.
So I can say that the first card, the relevant part for me is so I must again, now the list has an order. So the first element in the list is the ID number of the student. And the second one is, in this case, the physics mark. So I say 3 and 53.
3 and 53.
So this now
So I can unpack this. We know how to unpack this. We say first, then we get the
correct.
First of.
So this, what I had originally written as 53 now becomes 3 and 53.
Okay, then we write like that. So 3 comma 53, 24 comma 72.
Right. So now our list becomes a little bit more.
It's messy, but it's
elaborate. Yeah.
12 comma 64, 19 comma 78, and so on.
Okay. Very good.
So we have a list of. Should we call it something with this list of 2 elements?
Two elements. Two shoes, pair of shoes. Pair of shoes.
Pairs. Okay.
So we have pairs. So
pair is the list of 2 elements.
Right? It's just a list, but it has 2 elements.
2 elements. And it's easy to unpack the pair. I mean, there's nothing further to do. In a list, normally you take the first element, last element, the more to do.
Here you have only 2 things, right? So you have the first element and the last element because there is nothing
else. So you only have first and last, nothing else is there.
So in our case, the first is the ID and the second is the marks.
Second is the physics marks.
In this case, marks of physics.
Yeah. And so we made a pair, and then what we are doing basically is we are storing the.
So we are keeping as usual that maximum marks, and we are trying to check whether the second element of every pair is bigger or not. So in the end, we have found the pair.
When you are comparing the max variable, you compare the max variable with the
second
element of
the pair.
But
at that point, what we want to remember is, whenever we update it, we want to remember
the first element.
Who is that student? So we also store the first element as the. So that first element in this, if the maximum is unique, then we will get one
first element might be a list.
But if more than one student has got maximum mark, then we might want to accumulate a list of
first elements.
But every time we see a candidate for either this is an updated max or it is equal to the current max, we must extend that list. And every time we reset the max, we must reset
the list to 0.
To empty. 0 and just that one.
List empty and then
But the thing is that we can do it now in one scan. We don't have to go back to the cards and again look up who has those marks and all that. So it's useful to keep these kind of a list with some.
So it's a nice way, this list, and now we have got this list of pairs, nice way to digest very relevant information, right?
Yeah, so there's a lot of information on this, 7 or 8 items are there, but we don't want to keep the date of birth, we don't want to keep the city, we just need
whatever relevant information. So you could just keep, so basically with the ID, this ID,
Yeah.
along with the card ID, you are keeping the information of relevance,
Yes.
which could be physics marks, which could be maths mark, which could be chemistry marks, could be total marks, could be something else, date of birth,
Correct.
city, whatever you want, right? One property basically of the card.
Yeah. So one
One
identifier
property.
and one property.
One identifier and one property,
is what we are doing.
and that is kept as a pair. And then you make a list of pairs, and then you can throw these cards away and just use that list.
Correct.
And whatever you were doing with the cards, iterating over the cards and so on, you can now do with the list, and keeping one card aside, first card, the top of the table and all, we said something, right?
Yeah.
And then rest of the thing, same thing, top of the table, rest of the table
Yeah.
is top of the list, first of the list and the rest of the list.
Yes.
So precisely the same thing, same iterator we are using, and doing the same operations on the card, whatever we want to do, we are doing it on the elements of the list. So no difference, right? Nothing is lost, but all the irrelevant information has been discarded, basically, simplified. Yeah. So are there any other examples for this pair thing that one can think of, which will be?
Yeah, so I was wondering, I mean, see, because here we are saying that the first element is the ID which identifies whose mark it is,
Yeah.
but we might also be interested in knowing some relationship between these students, right? So for instance, have they performed similarly?
Okay.
So do they have,
Marks are,
yeah, which students have, it could be in one subject or more if their marks are within 10,
10, that is,
say in 2 subjects, or within, yeah, something like that. So supposing we say that 2 students whose marks are within 10 in physics and maths, both. In maths the marks difference is less than 10, physics also the marks difference is less than 10. If so, these 2 students have, let
similar,
us say,
very similar performance.
Yeah. So now you would want to keep every student ID 1 and ID 2.
It's a big iteration, huh? If you want to do that, you do nested iteration, right?
Yes.
You find such thing.
But then finally,
But the result is that you have got
you want to keep the information that you
Digested.
obtain from the nested iteration in some sensible way.
yeah.
So we would have to do that. So then we would have to essentially, so as an iteration it's easy, because we say for each say x in this list, right? And for each, let us say we are not worried about the fact that x is obviously within 10 marks of x itself. So we will just go through the entire list, all possible pairs for the moment. We can worry about it later on.
You will get the same, we'll get A comma A. No?
Yeah, we will get a comma a, but that's not.
This is a list of ID comma
Yeah.
ID comma marks, physics marks.
Yeah.
let's say.
So
right?
ID comma physics marks,
Ah.
and this may be a list of ID comma maths marks. No, we need
Both-
physics.
both the physics, both physics,
Both
yeah.
physics. Okay. So we are looking at people whose marks are 10 apart in physics.
10 apart in physics.
Right. So now we will say that.
For each x in this list of ID comma physics marks,
Yeah.
and for each y in ID comma physics marks, what do you know? What do you do now? You have to. So
we will have
x,
to check if
second of x,
yeah, last
of x,
last
second
of
element,
x
last of x,
minus last of y.
yeah, is within 10
Right. So I will just write this
mod.
absolute value is less than equal to 10. Okay. And now we want to in some sense record not
ID 1, you want to record ID of x and ID of y.
first of x
First of x, yeah. ID
And
of x is
first
first
of
of
y.
x, and first of y.
as a pair.
You want to record it, basically means you will put it in a list.
Yeah.
You will
so this
append it to a
means-
list.
Yeah. So this means we want to append it to of pairs that we start with a list which is empty.
Ah.
So every time we see an x and a y such that the marks are within 10, we will then add those two IDs to this pair. Now, of course, you will see x and x, you will see, if I see x and y, I will, a and b, I will also see b and a and all that, but that does not matter for now. Right? So,
you can discard, I mean you can figure out, because when you do this, if you can also say and
yeah, you can also add
first of x not equal to first of y, can say.
Yeah, or even smaller than. You can ask that strictly smaller than first of y. So, we will always record
only once, otherwise you will do it 2 times.
Yeah, so if student 5 and student 12 are related, you will get 5 comma 12, but I will not record 12 comma 5.
And you will definitely not have 5 comma 5 because it's less than.
Yeah, because it's less than. So, this will be a way to simply eliminate
all those spurious things.
Right. But the important thing here is not, I mean the nested iteration is of course something that is very easy and something we have done many times. But the important thing is that we are now storing the outcome of the, it's not just updating a count or looking for a max and updating the max value. We are actually accumulating some information with some structure, right. So, we are updating these pairs. So, that is another way of constructing a list of pairs where the pairs convey some information for us.
So, 2 ways we saw, right. One way is that the pair can mean an association of writing a property against a card.
Yeah. So, we have a list of properties, but we want to identify the owner of that property in some sense. So, we keep the owner ID.
Owner ID along with the property. So, ID with property, that is one way of using the pair. The other is ID with ID.
Yeah. So, we want to actually just look at 2 items and decide whether they
have some relationship.
They are connected or not, some relationship. So, ID with ID.
ID with ID. Yeah. So, those are pairs, and again when we finish the processing, what we are getting is a list of pairs. And that is some intermediate information we got about the entire bunch of cards.
Yeah. Then we can ask, for example, how many such pairs are there?
How many pairs are there?
Or which ID is similar to most IDs. Right? We can go through this list of pairs and we can check for each ID how many times it appears and then find out who is the maximum. So, of course, that will be very, again, time consuming, but it can be done. I mean, once we have done this, we have the information to find out.
Specifically, I mean, since we got this list of pairs, we got a list of pairs of people whose marks are in physics are similar. That's what I say, right?
Yes.
So, would that be a transitive relation?
So, transitive would mean that if A is similar to B and B is similar to C, so 3 students are like that, and the first student should also be similar to the last student.
We can check for that transitivity.
Yeah. So, now yeah, but just imagine that the first student has got say 74 and the second student has got 81. So, then they are similar because they are 7 marks apart, which is less than whatever 10. Now, if the second student has 81 and the third student has say 84 or 85 maybe, then they are also similar. So, we have say 74, then 81 and then say 85. Now,
but 74 and 85.
Yeah, so what we say is that these 2 are similar. These 2 are similar, but if I try to ask whether these 2 are similar, it's
not. But one could specifically ask when, I mean, how many?
That's also something we.
How many pairs of students are such that A and B are similar, B and C are similar, and A and C are also similar.
Yeah.
So we get these triples of three students who pairwise.
Yeah, or we could even ask more elaborate things like what is the largest
set of
group of students such that each of them is similar to each other.
All are similar to each other. Yeah. Oh my God, that's a hard problem. Huh?
Yeah, that would be a much harder problem, right? So we want to actually look for a set of students who are all connected to each other.
So that can be done by iterating over this outcome. So we have got a list of pairs.
Yeah.
We got a list of similar pairs, whatever we have created. We iterate over the list of pairs. In fact, in this case, we will do a nested iteration over the list of pairs, right?
Yeah.
So we will say for all items in the pair, so for all ABs which you are getting, all BCs you are getting, check whether AC is also in the list. How do you do that? I mean, that's you can write a loop like that.
Yes.
I don't know. I mean, I guess there is a loop, way of doing it, right? You will have to do 3 iterations, one inside the other.
Yeah. So you will pick up one item, one pair. We will pick up another pair,
such that,
and then you have to check that
whether
they have contain one
common element,
and then you have to check whether the other uncommon element is also. So you have to go through the whole
one more iteration again,
look for that.
My goodness. Yeah. So it's 3 nested iterations.
3 nested iterations. So every time you find a candidate, you have to go through the whole thing again to find out whether that's a.
It looks like, I mean, suppose I state this problem very simple way.
Yeah.
Whenever there is AB and BC, tell me whether AC is there. It looks very simple actually, right?
Yeah, but you have to do a lot of.
It seems to be, if you have a list, okay, it looks like a complicated thing to do. Okay. Yeah, is there a way to represent this triples directly? I mean, instead of trying to take pairs and make into triple and all.
Well, we can. Triple is just 3, right? So pair is 2, triple is 3. So we can just
list.
Right, it is a list of length 3, right? First element, second element, third element. First student, second student, third student, depending on what we are trying to keep.
So, we can have triples. Why don't we have triples?
So then,
so triple is a list of 3 elements.
Yeah. So triple would just be X, Y, and Z, something like this.
And how do you unpack that? So first element is first.
First element is easy. That is
easy.
First.
Last also is very easy.
That's last.
Now
of course, if we do this, so we can say first of rest or last of init.
Rest, okay. First
So this is either.
We know it's 3, so therefore.
That's a good thing.
That's a good
thing.
Always 3.
It's first of rest or it is last of. So I first take the first 2 elements alone by giving init, and then from that I pick out the last element, and that's the second element. Yeah,
so we can unpack it.
Yeah, we can kind of.
You can extract the elements.
Easily extract first, second, and third parts of a triple.
So triple. Then triple. I mean, triple makes sense sometimes because you may want to store some kind of thing where 3 things come together. Like the thing that comes to mind at least here is that you have a card. We were looking at sometimes the physics marks, sometimes we are looking at the maths marks.
Yeah, and you might want to look at both. And then try to identify whether there is some interesting pattern there or not.
Correct. Okay. So you may want to maintain a triple where you have the ID.
Yeah, so you could have like ID.
3, in this case 3, let us say. You have the maths mark. So second, let's say, is maths mark, so 42. And third item is the physics marks, 53.
Yeah.
So it's a triple.
For example, so 3, 42, 53.
And then you create triples out of this entire card. And then make a list of all the triples, and that represents all the information you need.
Correct.
About the card, its ID, its maths mark, and its physics mark. And then you can try to do something.
Yeah.
Right.
Yeah. So for instance, supposing you want to know people who are good in one but not good in the other. People who are good in maths but not good in physics. People who are good in physics but not good in maths.
What is not good again? We had decided earlier.
So we could say not good is below or above the average mark in that subject. So we have these triples.
First find the average.
Yeah, so you can go through these triples already and look at only the middle mark, get the maths mark, look at the average, compute the average of the physics marks. So we have this physics average and the maths average. And now we go through each triple.
Do a for each.
And check whether the maths mark is big. If the maths mark is above the average and physics is below. Or maths is below and physics is above. That means they have some
mismatch between the maths and physics marks.
And we can see now how many students.
And collect that into another list.
Yeah. So all those students who are in that category, we can put that into a list of people who have this unusual behavior and try and see whether there is a pattern why that's happening. So that's something that you can now do directly with the triples. It would be a little tedious to do if I had only the maths marks and only the physics marks, and I had to then again match up and so on.
Yeah.
So.
Okay. So, I mean, there ought to be some other things we can do with triples, right? Like for example, I mean, one of the things that we keep doing with this items list thing is we want to find out which customer bought from which store what item. Right?
Correct.
Huh? So we are not interested in many other details like how much it costs, total, and all that. Just want to know
name of the shop,
name of the customer,
and the
category
item. What type of item it was.
It's a triple. So C for customer, let's say. S for shop.
Okay.
And something for category. Let's say since C is already used for CSK. Let's say.
Customer. shop
Huh? Chennai guys.
and let us
Huh?
write it as category. You're saying. So that we have two different letters. So C, S,
K.
right?
Huh.
So this is our.
So,
So this is one triple for
triple
per card.
Per card. So let's shall we do what is it?
Not
Look
per card, it will be per entry in the card.
Per entry in the card. So here for example you will have Ahmed, SV stores, vegetables, food is one item.
Okay.
Or food, just we can say food, just say food.
Okay.
Another item would be Ahmed, SV stores. This also is food, so another food, like this.
Yeah.
Like this you will keep getting, right? And so you can basically unpack this card like this into these triples. And then a lot of things can be done, like you do all the cards like this, you will get a huge bunch of triples. And then we could do various things, like for example you can find out how many items Ahmed bought, which is store independent, you could have bought it from different stores. Or you can ask how many items did SV store sell, or just count the number of things where the middle item is SV, right? Or how many food items were sold, independent of who bought it and which store sold it, which is just count the number of items which have food in the last, isn't it?
Yeah. And
Or in pairwise also you can say how many food items did SV sell.
Correct. Or how many, yeah, which customer bought the most food items.
Which customer bought the most food items.
Or which store sold the
Fewest
or most or whatever.
Whatever, yeah. All these interesting things can be done.
Yeah.
All of them can be done just by triples, these triples, right?
Yeah.
So, I mean, what we are saying basically is that taking these cards, digesting information, putting them in the form of pairs or in the form of triples,
Yeah.
and making a list. Making a list of pairs and triples also a list, but we are giving them special status to them, right? Making a list of these pairs or list of these triples is enough basically. We don't need any more the card. After that we throw away the cards or keep it aside. Correct. And then we can work only with these lists, and the iteration which we used to do on the cards, go through the list of cards whatever way we did. The same iterator we now do with the list of triples or list of pairs.
Correct. So the relevant information is there in this. So all the unused columns, quantity, price, cost,
all are gone.
We don't have to specifically ignore it. It's already been suppressed in some sense.
And the advantage of using lists is that we only need to know how to work with lists.
Correct. So we need our basic iteration, and what we have seen now, this first, last, rest, in it, that seems to get us a lot of mileage.
Lot of mileage.
Yes.
Should we try a problem with these marks thing? I mean, I want to try a problem with marks thing.
Okay.
We tried earlier, we asked this question, right? Do people who do well in maths also tend to do well in physics? Okay. We found that that's not the case, at least for this set it did not seem to be the case, but maybe we were approaching the problem with a different way.
Okay.
I want to try it.
Okay, so how should we think about this? So if somebody does well in maths, for example, then they would be close to the highest mark in maths. So we can think of maybe ranking the students by maths
marks,
and seeing how well this person has done in terms of their position in this ranking.
And similar in physics.
So then, yeah, if they are doing well in both, then their ranks may not be identical, of course, but it might be similar. If you are doing well in maths and you are also doing well in physics, then
similar means close to each other.
They should be close to each other in position.
So the maths rank or maths position, and the difference between position in maths and difference in position. Yeah. Okay, so let's try that now. Why don't we try that? So suppose I want to make a list. So basically, what are we doing? We are creating a list of. We want triples, huh? No.
Let's see. We have maths rank.
What do we have?
We have physics rank.
So we have two pairs, is it? We should pairs. We have two lists of pairs.
Yeah, because it's
one will be ID with maths, another will be ID with physics.
Yes.
Right?
So we will have two lists with pairs.
One is
so we will have
arranged in ascending order of maths.
Yeah.
Another is arranged in ascending order of physics.
So let's say ID and let's just so if we just sort it by maths marks.
Should try it.
Okay.
It's too much to do with one shot, but we'll try as far as we can.
Yeah.
ID with physics
marks.
Maybe we can take a smaller set of cards.
I mean, we can just take some.
I think this is already ordered by maths, no? We'll take 10 cards.
Yeah.
Okay? Oh, it's not ordered. Oh, it is. Okay. We'll take some cards.
Okay. So
4, 5, 6, 7, 8, 9, 10. I've taken 10 cards. Okay? We'll see what happens here. So we have 342,
okay.
24, 44,
So I'll just write this vertically, this list.
Okay.
Yeah. So 24, 44.
44, 12, 52, 1956,
Okay.
257, 2262, 1762, 162, 963 and 1064. Right?
So these are our 10 cards. Okay.
Now I need to order these by physics, na?
Yeah. So you need to sort them again.
Okay, let's do it. Order it by physics marks. Is 45, 88, and 72. Okay. All right. I think this is correct. We'll see. 145,
Okay.
353, 254, 2262, 1264, 1072, 2472, 1978, 1781
Okay.
and 988. So we got two lists of pairs. This is maths. It's an increasing order of maths marks.
Yeah.
This is an increasing order of physics marks. What do we say we want to do?
So now we want to say, look at student number 3. So let us say the rank is,
Increasing order. Sorry.
so yeah, so let us say the rank is 10 because it's 1 to 10.
Yeah.
So the rank is 10 here. So then you say, what is the rank of student number 3 here?
9, that is.
Is 9. So 9 and 10 we can say are reasonably close.
Close.
So the person is doing equally badly.
You want to take
more
the
or-
average distance or something like that? Average distance you can
Should
take?
take the distance, or okay, the distance might tell us something about
So here it's
either
rank
we
1
want
and
to
rank
co-
2.
yeah, are
2
we,
minus 1, 1
we can
take.
do two things. We can either count how many students are very far apart in rank. I mean, if a student has rank say 1 in a subject and rank 8 in
Same
another
thing.
subject,
Yeah, same thing. You can do that.
then you
also,
can
yeah.
do that, or we can count the average. So we can say the average. Let us
Okay, let's do average.
So let
So
us say for
student 3,
yeah. So for student 3, for example, let me just get another piece of paper. So for student 3,
we have distance of 1. Huh?
yeah. So distance is, so here it is 1 and here it is 2, right? Or 10 and 9, whichever way. So let's make it 2 minus 1 is equal to 1.
Okay.
So now, so we have done this. So let me just write it off. So now 24. So here it is 2 and here it is 7.
So distance is 5. Huh?
Yeah. So for 24, the distance is 5. That's done.
This will be interesting to try as a iteration. What kind of iteration we are doing? Anyway, whatever it is, we are searching for this and that. That's all, no?
So,
And
yeah,
keeping
so
count.
12 is 3 here. So we are going down through this
Ah,
and looking for 12, and we find it 1, 2, 3, 4, it's 5.
okay.
So 12, the distance is 5 minus 3 is 2.
2. Okay.
So here we are going systematically. So 19 is 4. Now we go down this and look at 19 and we find it at 8. Right? So for 19, the distance is 4.
Okay.
For 2 is at distance is at 5 and 2 is here at 3. So 2, the distance is 2, 5 minus 3.
Okay.
22 is at 6. 22 is at 4.
Okay.
So the distance is 2 again, 6 minus
Yeah.
4. 17 is at 7, 17 is at 9. So the distance for 17 is again 2, 9 minus 7 minus.
Okay.
1 is at 62, it's at 8, and 1 is at 1.
My God.
So 1 is a
Outlier, huh?
outlier. So 1 is a
7.
distance 7. 963, 988. So this is quite close, 9 and 10. Distance is 1. And finally 10 is at 64 and 10 is at 72. So 10 minus 6 is 4.
Okay, let's try the average. I don't know what it comes. Let's see.
So let's say the average is 6, 8, 12, 14, 16, 18, 25, 26, 30. So average is 3.
Three is less than 5 at least. So
Yeah,
3.
so 3 ranks apart, which is roughly 1/4. I mean, 2.5 would be 1/4. So it's a little more than 1/4, but less than 1/3. Not too bad, right?
It seems to have some correlation maybe there. Right? I don't know.
So-
This is a way of checking. I don't know.
So we should try it out maybe with all 30 cards, because
Yeah.
we kind of looked at
Already-
the 10 bottom marks in math, so it's
Ah.
not really a representative sample. The physics marks were not pre-selected. So we should try it out with all 30 cards and see how it works. But this is something where you can do something interesting with these lists of pairs. So,
But here we are iterating, because here right, you're taking the first out and then the rest and
Yeah.
all. Here you're not doing that. Actually, you're doing something else.
yeah. No, so here what I did was I iterated through this, and for each of these I had to actually go through a full scan of this, looking for that thing. So
You don't have to remove it. You struck it out, but
yeah, I
don't
struck it out only to make sure that we are not
doing it again.
that we have not missed anything that while writing it down.
So
but
actually,
yeah.
strictly speaking, you can take the first here, go
Yeah.
through this. Yeah.
So it's a
Wherever
nested
you find-
iteration.
Nested iteration.
You go through there. Once the moment you find this ID, you mark, subtract, find the absolute value, note it down, and go on. So really, this is also a list of pairs,
List of pairs.
right? ID with the difference.
Yeah, ID difference. From which you can find the average.
Yes, from which you find the average.
Nice.
Of course, we could just keep the average without the IDs, but it's then we can see who is, like, we now
We know
that
this outlier,
student
whether-
1 is bad, and some students are better, like 9 and 3 are very close to their thing, and so on.